analyzing a graph, getting the characteristics. So we got the period of the graph up here. We actually got domain and range of the graphs as well. We're going to do more of those later on. But now the next one is we are now going to analyze, the same graph here, right? But we're going to analyze the midline and the amplitude. Now the midline is just what line cuts this graph straight in half. So if I were to draw the midline on this thing here, we use this little fancy color graph here, or color thing to do. I'm going to draw a line that goes right down the middle. Most time you just eyeball this. There's my midline. And what I'm going to do is I'm going to give it a name. I'm going to give it an equation, right? So what would the value of the midline be as an equation? So since I drew the line, you notice that it crosses the y-axis. I just have to determine where does it cross the y-axis. So right there, if I were to do the math, then that's halfway between 2700 and 2200. Describe what happened to what the midline does. What the midline does, midline cuts the graph in half. Yep. That's a general way of saying that. Now, how do we get that number? Now, if you know the scale, you can find out what that is, but I'm going to mention something about the min and the max. So we have a min and a max here. So we have a min and we have a max. How do I use those? Because the midline is going to be halfway between those two. So how we find the midline, where does it cross, is we can create an equation, right? And you're going to see this equation later on. To find this, you're going to take your max value. You're going to add it to your min value. There's a plus sign there, sorry. I probably should get away from this pen here. And what you're going to do, because it's halfway between those two, you're going to divide by 2. So you're going to take the 2700. You're going to add the 2200. You're going to get a big number, but then you're going to divide it by 2, and you're going to get 2450. So that is the halfway point on that graph. You can just look at the scale and try to figure that out too. You can do the same thing we did before. Like there's 4 boxes between these two. It's a bit trickier to do, so I'm going to take the 500. There's a 500 difference between the 2 boxes. So from here down to here, that's 500. I'm going to divide it by 4. Technically, you could just divide it by 2 now if you wanted to. So it's 250 to get to the top. And so I'm going to go 2200 plus 250, and you get 2450 as well. Now, I want to represent this as an equation of a midline. Because it's horizontal, the equation of a midline is always y is equal to 2450. So y is equal to make it a horizontal equation. When we talk about that in polynomials, this is what we call a constant graph, a graph that is just a straight line across. You could just plug that into Desmos and you can get the same result too. Okay. So amplitude. Now, amplitude of a graph, if I were to measure it from this graph here, or they'll give you a little terminology down here too. Amplitude is the distance from the midline that we just created to either the min or the max. It doesn't matter which one because the midline splits it right in half, so it doesn't really matter. It's always expressed as a positive number, so it doesn't matter if you go down or up. You always just say it's a positive number. And then it's always a positive value. But those 2 dots, I should check this later on, these 2 dots are exactly the same. It's always a positive number. Maybe I just want to emphasize, it's a positive number, never a negative number. So what's the amplitude of this graph above here, right? So one way to do this one, to find mathematically, is a very similar formula to find in the midline. You can take the max, you minus the min this time, rather than plusing the min, and then divide it by 2. I mean, I kind of already did this when I went through the other step before. The 2700 minus the 2200 divided by 2, which is 500 divided by 2, which is 250. That's my amplitude. It probably has units, 250 milliliters. All right, this is in milliliters up here too. I didn't put that there. Okay. Otherwise, you could just look at that graph and measure upwards and say, okay, I want the amplitude, so here's my midline. I'm just going to go right up to the top here. That's 2 boxes there. And I decided every box was 250 or every box was 125 or something. There's 2 of them. You can easily figure that out. So when in doubt, you're like, which the plus one and the minus one? Do both, and whichever one makes sense for the question is your answer. Here, just one second. Okay, so let's look at these graphs here and try to determine what's the midline. As it says, what's the equation of midline, and let's draw the midline. What's the amplitude? You could just show that on the graph, and we'll actually just calculate what it is or measure what it is, and we'll highlight what the period is. Highlight, maybe just determine it or show what is on the graph here. So let's go through and let's draw the midline. So you could just eyeball this. You could say, okay, it goes high 3, -1. So my midline looks like it's going to be right about here. Here's my midline. I'm just going to label that. Midline. Cool. There's my midline. Show the amplitude. So from this line, from the line we just drew, the amplitude looks like it's going to be this tall. All right, there's my amplitude. Okay. Highlight the period. So the period, one graph is going to be from lots of different ways you can, but if I draw from the 0, it's going to be this part of the graph right here to here. From there to there. You notice that's going up through the midline, down through the midline, so that's not going to be a period, and then it's going to go back up through the midline here. So when it's going back up through the midline again, so that's one period. So the period is from here to here. That's my period. Okay, and the equation. So I could do this. I can actually calculate some of these now. So I calculate what is my amplitude, what's my midline. So the equation of the midline here is y is equal to 1. That's the equation. So I can't just say the midline is 1. I have to say the equation of the midline is 1. The amplitude here, the amplitude is just a number. So the amplitude is 2. It goes from 1 up. So 1, 2. So its amplitude is 2. Okay. We drew the midline. And the period from 0 over to 4. So the period is 4. Now, there's no units on the axis here, so I'm just going to say 4, unitless 4 here. And my amplitude is just 2 as well. There you go. Here's a typical sine graph, which I showed you before, right? What's the period, the amplitude, the domain and range? We didn't do the domain and range for the one up here, but for this graph, what's the period and amplitude? Domain and range, the number of x-intercepts per cycle, per period. So this word cycle here, which is another way of saying period, might be revolutions, how many times around, lots of different ways you can say the same thing. This is essentially per period. Okay, so let's figure out of this regular sine graph. This sine graph is in degree mode. You notice that when I did this before in the Desmos, you can go to 2 pi or go to 360 depending on which mode we're in. We're in degree mode. So that means my period is going to be from here to here. You can see that these 2 spots starts here, goes up, down, then back up through that same area. So I get a period of 360 degrees. Now this one has units because it's in degree mode. The x-axis is in degrees. Okay. Now the amplitude is just going to be measured from a midline. The equation of the midline, might as well just do that right now. You notice the midline right now is right down the middle. Right? That is y is equal to 0. Right? Y value is equal to 0 there. Makes sense. So my amplitude is measured from here to the top of the graph or from here to the bottom of the graph. Both the same. It's 1. My domain is going to be XER. In most cases, the domain will be XER. Most cases. Our range is going to be from our lower number, -1, to our higher number, +1. And we'll be using less than signs there. Just put little curly brackets around these to make it look nicer. There you go. Cool. Oh, yes, number of exponent steps per cycle. Now, a cycle is when it gets back to where it was before. You can see here, it's going from here, crosses 3 times. There you go. Cool. Now, when you're doing this in your calculator, if I want to just do this in my calculator really quickly and I want to see what this looks like, here's my calculator. Okay. So I'm going to go over here. I'm going to hit sine. Okay. Apparently it doesn't let me type that in. So I'm going to have to sine x. Okay. I'm going to hit graph. As you can see here, the graph looks pretty good. But if it wasn't, so I'll show you what it looks like otherwise. So if I had in my mode, if my mode was in degrees, and I hit graph again, you might get something that looks like a straight line. If you get something that looks like a straight line, it just means that your axis here is not on the proper scale. So an easy way to do that is to go zoom, and you go zoom trig, number 7. And then it just puts our axis back to the way it was. And you can double check in a window what that does. It just goes from -495 to +495. Right? You can change those to whatever you want, but that's just the standard here. And they just make the scale on the bottom every 90. So every tick here, 90, 180, 270, blah, blah, blah. Now, if I was in this mode, and then I typed in my radians by accident, I would do this, you might get a graph that looks like this. Looks a bit crazy. It's going all over the place. It's just, again, because the scale is going to be off because 2 pi is around 6. But this is going to 360, so there's a lot of graphs in here. So I can go zoom trig again, and then it puts it back to normal. But because the mode is in radians here, so you hit mode and you see radians. Because the mode is in radians, it changes the min and the max here to be in radians. This is 495 in radians. Right. So now if I go back and I say, okay, now put my mode back to degrees, and I hit graph again, I'll get to that straight line. So every time you get a straight line, you're like, I shouldn't get a straight line. What's happened here? Go zoom number 7 and just put it back to the way it was. You could change the window afterwards to make it look a little bit nicer. But that's essentially how that works. There's also just telling you here to ensure it's in radian mode. You can change your windows to be these if you wanted to. You can type in your calculator. When you go to window, you don't have to have, so say my mode was in radians. Let me go back to radians here. Go zoom number 7 here. Now, I don't have to type in 3.14159. If I want this to be pi, I could just go pi. I can put a pi there. So there's my min, right? Maybe I'll put negative pi because that's my minimum value. And then I want to go positive. You notice that I just changed the decimal here. Maybe I want to go to positive 2 pi. That's 360. And then I'll just change the decimal. And now we have negative pi to 3 pi. Cool. Okay, in the next video, we're going to talk about equations. How do these 3 things that we did up here, the period, the midline, and the amplitude, how do they change what the equation looks like? And you notice when I did this in my Desmos here, I just typed in sine x. Sine x, and I got this graph here. How do I change this? How do I make it so it has a different amplitude? Well, maybe I'll put a number somewhere. Maybe I'll put a number in the front here and I get a different amplitude. How do I change that so it has a different period? So maybe I'll put another number somewhere else in this equation, like that. And I'll change my period a little bit. I'll go back to my regular amplitude, right? Or how do I move the graph up? Maybe or move it down. Maybe I'll subtract a number from it. It'll move the graph down, right? We're going to look at something else that's a little bit more complex, but maybe how do I move the graph side to side so it doesn't always just start in the same spot? Let me just get rid of this. Maybe I'll have to put in a little extra piece in here so I can move the graph sideways by putting different variables, different parameters in different spots in this equation. I can move the graph around to match a situation. So you're going to see that in the next lesson here. Okay, I'll see you then. Bye.